Good morning. Hopefully you can hear me all right. Let's see. Well, it looks like I got to adjust. Let me know if the audio is working. I got a crackling TV back here, so I got to take care of that real quick. Let me know where you're from. All right. There we go. Yeah, that was fun. So I was talking, and all the TVs were picking up on the audio, and it was a bunch of static, and everything was going all over the place, which is very interesting because that didn't happen all morning long, same mic. But anyways, that's how technology works. Good Monday. We'll get started here shortly, here in a few seconds, as everybody else hopefully comes in. I'll get loaded up here on my other computer. And we are starting off the day here with some nice weather outside, so it may be a little tempting to get outside and enjoy it. Finally, some warm weather coming up this week. But we are talking about regional weather today, tomorrow, and coming up on Wednesday. But today is special because the regional weather we're talking about is right here at home. It's Great Lakes and how it all impacts us. And so it's obviously, we experience these impacts all the time, whether we realize it or not, which is pretty neat stuff. So this is Getting Schooled, and if you haven't been with us, this is week number 6. We've been doing these daily little weather or science-related episodes, kind of teaching new lessons along the way. We've been through a lot of fun stuff already, like forecasting and space weather, and we did obviously a lot of with astronomy and earth science and a lot of various weather-related topics. But this week is all regional weather, today, tomorrow, and on Wednesday. Today we'll talk about the Great Lakes. And here's the lineup. I'm excited about this week. I think about every week I've been excited about these topics as they're all very interesting. But today we talk about the Great Lakes weather. Tomorrow, the Arizona monsoon. So that isn't close to home at all, but it is a fascinating topic, and it's a much different type of weather than what we're used to. And tomorrow we talk about, again, the monsoon, which has, believe it or not, virtually nothing to do with rain. Everybody thinks monsoon, they think downpours and rain and heavy rains and all that, although it's not what the weather term means. So we'll talk about dust storms and lightning storms and sometimes even severe weather and all the things that come along with it and why it happens every year at a very specific time. And then on Wednesday, we'll talk about mountain weather, which it can be pretty fascinating too. In some ways, there are some similarities between certain types of mountain weather and what we get here in the Great Lakes, although we don't really have mountains altogether. And then next week, winter weather. Even though it's warming up, we're going into May. That's a topic we haven't talked a whole lot about yet. So let's get right over. We'll talk about lake effect snow. And by the way, great to have you. Even if you're not watching here in Northwest Ohio, it looks like we've got several that are watching kind of around the country today. And welcome. It doesn't matter where you're from. We're just glad that you're here today, and certainly pretty exciting stuff. Again, we're talking about Great Lakes weather, but these little lessons that we'll be talking about, around the country this week is certainly kind of applies to everybody, kind of learning something different about what makes the United States great in each different little corner of the country. But for us, lake effect snow happens quite a bit around the Great Lakes, and yet in Toledo, where a lot of us are from, or Northwest Ohio or Southeast Michigan, we don't get a whole lot of lake effect snow. Even though we sit right beside Lake Erie, but then on the other side of the lake, they get dumped on. So we're going to talk about why. Lake effect snow, pretty fascinating topic, I think, because you can go from one spot and get dumped on and have 4, 5, 6 inches of snow, maybe a foot of snow or more, and then be a few miles away and not get anything at all. So lake effect snow happens when the water temperature on the Great Lakes warms up and it stays warm. And so here's the deal with water temperature in general, is that we have water takes a lot longer time to heat up or cool down than the air does. It's just the way that it works. So if you were to, you think about your swimming pool, or you think about any lake or whatever it may be, it gets really cool in the morning, but we don't have the water that cools down that abruptly. But on the flip side, it takes forever, it seems like, for that water to warm up. How many of you guys have gone to a swimming pool or a lake or anything like that in the early part of summer or right after you filled that pool up and notice that water is cold? Even on a hot day, that water takes a long time to warm up. Well, once that water becomes warm, it takes a long time for it to cool back down too. So with that warm water that is sitting there, all of a sudden if you get an abrupt change just like that and the cold air begins to stream in over the lake, all of a sudden it's like putting maybe if you had hot chocolate or a coffee or just a cup of hot water and then putting it in the freezer all of a sudden. It's going to take a while for that water to cool down or that hot liquid to cool down. You can see steam rising all over the place, right? Well, those are basically clouds rising up from all that hot water. And so lake effect snow essentially happens the same way. You get cold air that comes over that warm lake. It creates the steam, the clouds form. And then as that moisture runs into higher ground, it's almost like running into a small mountain. And that air, it comes in and it forces it to go up. And so that combination of taking that warm, moist air and clouds that are already there and forcing it up even higher is going to create some precipitation. We can get lake effect rain, it is possible, but generally when this happens, it's lake effect snow. So the cold air comes in over the Great Lakes. You get the clouds to form here, and all of a sudden those clouds go up. There they go, and then they run into the ground, and it creates that snow that begins to fall and eventually can add up. And in some cases, if you're downwind, and that's the key, you got to be downwind of the Great Lakes, you can get absolutely dumped on when it comes to snowfall. So let's look around the Great Lakes. Toledo, we get about 37 inches of snow a year. We do get a few inches of lake effect snow, but look, when it comes to Lake Erie, we don't get much at all on a normal year. Cleveland gets about 54 inches of snowfall a year. We're not that far away from Cleveland. They get 54 inches, we get 37 inches. You go to Erie, Pennsylvania, and there's a drastic increase here. Even from Cleveland to Erie, there's not much difference there. What is it, an hour and 15-minute drive or so from Cleveland over to Erie, Pennsylvania, right along the turnpike? Cleveland gets 54 inches of snow a year. Erie gets 101 inches of snow every single year. Buffalo's on the other side of the lake. They get 93 inches of snow a year. We get 37 inches. That's like 2.5 times the amount of snow that we get. Absolutely incredible. So the only difference there is that the winds generally, you kind of see the arrows are coming in the wintertime from the northwest. You get a big blast of cold air, and that cold air usually is driven in by winds out of the either north, west, or northwest. And that's why areas to our east get hammered with a lot more snow. And it's like this on all of the Great Lakes. I want to take you up to Lake Superior because this is a totally different ballgame. Lake Superior is massive. It rarely freezes over. It holds lots and lots of energy when that water warms up. And it's almost always cold enough, it seems like, to get snow in the wintertime in the UP of Michigan, so the Upper Peninsula. There are spots in the southern part of the Upper Peninsula that still get lake effect snow, just not nearly as much. And you can see it there on the screen. They get about 70 inches of snow in the southern part of their year. That's a lot of snow. That's like double what we get. But look in a very small distance here. Maybe I can even draw how far away it is. You go north, what is that, 50 miles? About 50 miles roughly to the north, and they get 200 inches of snow a year. They go from 70 inches to 200 inches of snow. You go over towards Marquette, they get 100, well, this is not in Marquette, but just to the west there at Marquette, 150 inches of snow a year. And then how about this? In the Keweenaw Peninsula, and this little area here that kind of sticks out, that spot gets just blasted with snow, unlike any spot anywhere around us that does. I mean, you got to get into the mountains to see something much more significant than that. And that is 276 inches of snowfall a year. That's unbelievable here. In fact, let's see, 276 and divide that by 12. How many feet a year is that? 23 feet of snow. 23 feet of snow. That's what they get there in the Upper Peninsula of Michigan. Yeah, some of it's driven by normal snowfall, but almost all of that is, about 80 to 90% of it anyways, is driven by lake effect snow. And the thing is that you've got that big lake there that holds on to, because it's such a large body of water, it holds on to the warmth that it gets over the summer for such a long period of time. And so that's a pretty interesting thing that we get to deal with, even if we don't get the snow. And we do get a little bit of lake effect snow. Most of ours in Northwest Ohio, Southeast Michigan is actually coming from Lake Michigan. But there's something else that happens all the time. In fact, we're going to be dealing with it over the next few days. And this is a pretty normal thing. The lake right now, it's the opposite. It's not holding on to warmth, it's holding on to cold. So again, if you were to try to go swimming in Lake Erie, that wouldn't feel very comfortable because even though the temperatures haven't warmed up a whole lot, certainly the amount of warmth that we have in the lake is not there. The temperature right now is in the 40s on the lake. It's very chilly. So because of that, the lake right now, it doesn't heat up nearly as quick as what the land does. And with the land, as it heats up, right, I mean, even today we're going to have a high in the mid-60s. Tomorrow, 70 degrees roughly. So the land heats up, and we talked about high and low pressure not long ago, a couple weeks ago or so. And with low pressure, you get rising air. Well, with the land heating up quicker, it essentially creates a mini area of low pressure. And so the land here surrounding the water is going to warm up. The air is going to rise somewhat. And as it does, it creates this little circulation right around the Great Lakes. And this is why we get these lake breezes, whether they happen on a regular summer day, which is pretty typical, or whether if it's driven in by more of a northeast wind. It's a little more of a dramatic setup here when we get the winds that are being pushed off of Lake Erie. But regardless of how this ends up going for us, when you end up getting this circulation to form and you get this breeze that comes off of the lake, it is going to be cold this time of the year. It's not very comfortable. We know that. Anytime we talk about a lake breeze in the forecast, it's usually not a comfortable thing for us, because when that breeze comes off of Lake Erie and Lake Erie is cold, it pushes that cold air inland. And a lot of times what will happen is that, and you're going to see it, I'm going to show you a couple graphics, but a lot of times what happens is that the land heats up first, the temperatures around the land heats up, and then we get that push of some air to develop here off of the lake and moving inland. So as the air rises, that air ends up going up. The breezes ended up going towards the lake, aloft, up in the air, and then you get sinking air over the lake, and then it pushes inland all the way around it. So it's this little circulation that just keeps on going around between high and low pressure, and it creates this little circulation cell. And even on a calm summer day when there's not much of a breeze at all, this still develops. So we're right along the lakeshore. It's going to be a little cooler until that lake warms up. Now, Lake Erie is so shallow, it warms up pretty quickly. Lake Superior is a different ballgame. Lake Superior holds on to all that warmth. They get dumped on with snowfall. But this time of the year, going all the way into early summer, it can be quite chilly up there in the UP. And this is part of the reason, because you get that breeze that's coming off of the lake, and it takes forever. Lake Superior never really warms up that much, it seems like, during the summertime. It always seems like it's pretty chilly. So let's take a look. I want to show you this graphic because I've got some of the lake temperatures that are on there right now. And then I've also got the actual temperature we have right now. So in Toledo, it's 55 degrees right now. Chicago, 61, 60 in Traverse City. That's some really warm air. And then you look at the actual Great Lakes. Look how cold that water temperature is compared to the Great Lakes. Traverse City, 60 degrees. You go northward there to Lake Superior, and we're in the mid-30s for the water temperature. That's a huge temperature difference there. Even Toledo, 55 degrees. Water temperature off of Lake Erie right now is 46. You go a little bit further east, it drops to 44. So that's a pretty big temperature difference already. So watch what happens here is that little breeze kicks in. So we've got these arrows here that are on the screen, and you see these arrows are showing you the wind direction. Now tomorrow, it starts off where it's more of a southwest wind direction for everybody, right? 70 degrees? My goodness, we've only been at 70 degrees twice this year. So finally we get up to 70 for a third time this year. But then you can see as we go later into the day, that little circulation begins to develop, and you get that little push of air coming right off of Lake Erie. And tomorrow the breeze is more out of the east to southeast, so it's not going to affect everybody equally, but it is going to be moving into Monroe County, right along the lakeshore, parts of Ottawa County there, Marblehead Peninsula. Look how the temperatures are cooler. Everybody's upper 60s, around 70, but Monroe, a little colder. Port Clinton and Sandusky, barely 60 degrees. Now, sometimes if it was a stronger wind, it would be even more dramatic. But this happens all the time. And so this is kind of an idea, kind of a look of what's happening with those different breezes. It doesn't just affect the breeze. It doesn't just affect the temperature. It doesn't just affect the snow. It affects everything. It affects when we get our frosts and freezes, because in the fall, as Lake Erie warms up and holds on to that extra warmth, it's really difficult to get a freeze or a frost near the lakeshore until much later in the season. What does that matter? Well, it affects the growing season because of that. That means that we have a later growing season along the lakeshore. It also means the leaves don't change colors as quickly as what they do inland. And this happens up in Lake Superior, up in the upper part of the peninsula of the UP of Michigan. There we go, the UP of Michigan, where you've got Lake Superior, Lake Michigan. You got all these lakes kind of coming together. And you get all these microclimate zones that are there because of the lakes, the different water temperatures, the valleys, the hills. And you'll see peak fall colors anywhere from late September all the way to the middle of October over the course of a 3-week span, where that's usually pretty unusual. You go to Wisconsin, get away from the lake, and it's pretty much like that. Everything's going to be the first few days of October or late September, if you go far enough north, to where the UP Peninsula, the UP of Michigan, there is much different. So even for us, this is a look at last year's peak fall colors. It was really late into the season already, but it was around Halloween, November 1st, November 2nd or so for most of us along the lakeshore. It was a good 5-6 days later than that before we had our peak colors. And here's the part about the Great Lakes that I don't like. I love the Great Lakes. This is the part of it that I do not like at all, is that while we do get some lake effect snow, and that's interesting to track occasionally, we don't get the lake effect snow as much as we get the lake effect clouds. And we get a lot of lake effect clouds that develop. So this is a look here at a graph of our cloudy season and kind of emerging from it. In the middle of December is the cloudiest time of the year in Northwest Ohio and Southeast Michigan. It's because as that cold air comes over the Great Lakes, it produces the clouds. And while we don't get much out of in the way of lake effect snow because we're too far away from Lake Michigan where we're getting the source of that to develop, we still have the clouds. The clouds don't go away. So we'll go day after day after day of just gloomy conditions. Only about 30% of the time do we have sunshine in the middle of December. It gradually goes up there in January and February. And then as the lakes begin to freeze over or the lakes just become cold in general, they don't produce as much clouds anymore. And all of a sudden, that begins to go away. And by the way, I'm kind of hiding things here, but you go March 15th, April 1st, there's 50%. Whoops. Let's try this one. So 50% here. The middle of April, we're kind of right here. So notice we're starting to get more sunshine now. It's about 50-50. But then as we get into early May, that jumps to 60% of the time. So we're getting there. We're starting to emerge out of this cloudy season. And then it goes all the way through the summer. Actually, our sunniest time of the year is like August, September. Early October is not bad. And then as soon as the cold air starts to come in and we start to get that transition, it goes like that in the amount of sunshine we get. By late October, we're done. We're stuck in a cloudy season. So that's a look at how the Great Lakes impacts our weather here. Again, tomorrow we're going to be talking all about the monsoon, Arizona monsoon. Fascinating topic. I know that obviously we're talking about Great Lakes weather today, and that impacts the majority of you that are watching. I did see that we did have somebody from Arizona watching us. Tomorrow, come back and watch again because it all has to do with the Arizona monsoon that affects not just Arizona, but New Mexico, all of northern Mexico, California, Utah, Colorado gets a lot of that influence. But it is a fascinating thing because Arizona, really the weather in Arizona is absolutely fascinating because you can go anywhere from severe weather, and then also there are spots that get more snow than what we do, and we don't typically think of that. As a kid growing up, I thought of Arizona and cactuses all over the place, and they do have a lot of cactuses in the southern part of the state, but it's not everywhere. So it just depends on where you're at. Totally different climate zones, but you get some intense summer storms there into the desert due to these monsoon thunderstorms. And again, it happens every year at about the same time. So we're going to talk all about it tomorrow. I can't wait to talk about that. But anyways, I'm looking for questions. If you've got questions on the Great Lakes weather, how it all operates, how it works, something else that we've talked about in the past, astronomy, earth science. My goodness, we've talked about a lot already. We've got talked about tornadoes, we talked about hail, lightning, weather technology, radar, satellite, computer models, weather balloons, brought in that weather balloon. Talked about clouds and fronts and forecasting. Of course, the northern lights last week, meteors and eclipses. And by the way, for those that are wondering, so we've got this week, which is all about regional weather. Next week, we'll talk about we're talking about winter. So polar vortex, blizzards, thunder, snow, ice storms. Again, kind of seems inappropriate that the first week here or second week of May, essentially, that we're going to be talking, I guess it'll be first week of May, that we're going to be talking more about winter weather, but it's still going to be fun. We'll talk about all the details of that. The week after that, world weather. So we'll talk about climate, El Nino, And then also we'll talk about the Toledo weather stories, which I just got my list of everything I'm going to talk about for that. And Toledo's got some really interesting weather that's happened over the years. So we'll get to all that. And then the final week, coming up later in May, we'll talk about summer, the changing seasons, and hurricanes. I know there's a lot of tropical weather fans out there. I didn't forget about you. We've put it intentionally close to the beginning of when the tropic season begins for us. The hurricane season begins. And then, of course, extreme heat. We'll get to that, too. But to go ahead and get your questions in here. And, yes, by the way, seeing that I should not have said cactuses. It is cacti. I knew that. But thank you for making that correction there. But anyways, love Arizona is one of my favorite states, and I can't wait to talk all about the Arizona monsoon tomorrow. See, Diane asking, I've seen frozen waves on Lake Erie. How are those formed? That's a good question. So we get basically what's called ice shoves. There's a couple other terms for it, but ice shove is one of the most popular ones. And so what happens is that Lake Erie is always moving and changing, and even when it does freeze over, this past winter it wasn't that severe for us compared to what we typically have, so the ice amounts on Lake Erie were quite minimal at best. But typically when you get the ice, it begins to form, and then you get some movement, and there's always movement. The water's moving underneath the ice. So you get these currents underneath the water, you get the winds on top of it, and so that's trying to shift and move things around a little bit. And when those winds get strong enough, and as you know, we can get some powerful winter storms many times with strong winds, that ice can sometimes begin to kind of crumble up and slam up against each other. It's almost like an earthquake on the water. It's the best way I can think about it. Those big sheets of ice are kind of like the big plates that we have, and when the winds all of a sudden begin to shift, it begins to end up pushing different sheets of ice into one another. And again, just like an earthquake where the two crusts come together and there's movement there, or just like if air is going to run into a mountain, it's got nowhere to go but up. In that situation, a lot of times if the two different streams of air are coming together, you're going to get the ice to kind of come up together, and it begins to form that. And a lot of times that happens right along the shore. It can't really go anywhere except for up, and it begins to pile that ice up and creates quite the formation. So a lot of times it happens when weather is changing. You get the strong winds, obviously, to help form that, but also when you're in that freeze-thaw cycle that's out there on the Great Lakes, you get that to happen quite a bit, where the ice begins to really pile up. And it can be dramatic sometimes when we get that. So ice shoves is the term for that. Let's see. Jennifer asking, what time of the year does it strike or come in as lake effect? So when we get the lake effect snow, usually that comes in, it comes in when it can develop any time where the temperatures are cold enough for snow and the lake is substantially warmer than the air aloft. But that happens much more often, say, as early as October. It is not unusual at all, especially for, say, the UP Michigan to start getting a little bit of snow by Halloween, if not a little sooner than that. November, though, December, and January are the three most popular months for lake effect snowstorms to develop. Can it happen in February and March? Yeah, but it's really unusual because by that point, usually the water is freezing up. And if the water is frozen, even if the air is dramatically colder than the temperature right on the surface of the lake, that ice is going to help prevent the amount of evaporation and steam to go up. Think about it. If you were to put a cup, remember we talked about putting a cup of coffee or hot chocolate or hot water of some sort into the freezer, and then you could just see the steam rising up, and it's kind of like our lake effect clouds. Well, imagine doing that, but before you put it in there, you put like aluminum foil or saran wrap or something like that over the top of that cup, and then you put it into the freezer. Well, there's still going to be a little bit of steam, maybe trying to sneak around or try to find a way out, or maybe just the cup, because it's hot in itself, it might steam up a little bit, but the majority of it's going to be gone. And so by the time the lakes freeze up like that, it pretty much eliminates the amount of lake effect that can take place. So usually by February, March, we don't have that. This year was so weird, so strange that we really didn't have a whole lot of lake effect because it never got cold enough. And then we had these blasts of cold air come in later into the season, and then it kicked off lake effect snow. I mean, the conditions were still right for it, but that's just very unusual to get it late in the season like that. See, can the lakes be 10 degrees cold? Yes and no. I mean, at 10 degrees cold, by that point, they are freezing up. And so the ice itself can definitely be 10 degrees cold or colder, no doubt about that. But again, it's pretty tough to get that water in a liquid form with the water being that cold, because it's going to end up freezing up. Now, if this was, say, the ocean, that's a little different of a story, because the freezing temperature of the ocean is a little bit closer to the mid-teens or so for temperature-wise. So you can get some of that water to be much colder and not freeze up if you're, say, out in the middle of the ocean. But it's much more difficult when it comes to the Great Lakes. But again, the ice temperature itself can be 10 degrees. All right, looks like that's all the questions we got for today. Again, I hope everybody comes back tomorrow. We'll talk all about the Arizona monsoon, or North American monsoon, or however you want to look at it. But again, it's one of my favorite topics when it comes to different weather patterns that are out there. Obviously, the Great Lakes are near and dear to my heart. I grew up here and work here, but I love taking trips out to Arizona during the middle of monsoon season. Just to kind of watch everything in motion and to watch some of these storms. So anyways, I'll see everybody tomorrow, and hope you have a good day for the rest of it. Certainly a nice, bright, sunny day outside today. Bright, sunny day.